So when we talk about retaining compounds, really what that really it means is it's just a method of holding together cylindrical fitted assemblies or fitting components. So when you think about that, you talk about bushings, bearings, gears, pulleys, etc. And some of the more common ways that they're held together, as you see there now that Ryan's got that back up, are, a keyway, set screw, press fit, shrink fit, sometimes the splines, but all of these methods of holding these assemblies in place have some deficiencies. So when you think about a keyway and a set screw, they're really the point of contact is in force is focused all in one area. So that keyway, over time, you have those hard starts and stops. That keyway gets wallowed out, so that's not as reliable then. The set screw, same thing. And Ryan mentioned one of the fact with the thread lockers is that if you don't have a thread locker on that set screw, through the vibration, the thermal cycling, whatever it might be, that set screw can back out. But the other issue there too is it's one point where the majority of the force is located, and that can cause problems whether you're scoring the shaft, whether it's wearing down the set screw itself, and then that assembly is no longer good. So one of the other major issues with the keyway, and then in particular spline shafts, is that they're really, really expensive to machine. So that cost benefit analysis, I guess you will, is one of the things you have to take into consideration there. Obviously, in today's environment, manufacturing stuff faster, it's not always as good. So when you get these parts in, the machining is not always what it should be. So, and now you basically have a slip fit, which I don't know if Ryan's going to demonstrate that or not. He seems to be going in and out. So, but that strength depends on the coefficient of friction and the pressure between those components. So again, it's not the reliability isn't there. So when we talk about those things, we like to use an anaerobic adhesive, machinery adhesive, also known as our retaining compounds. And they're applied to the parts, and they can either be a standalone or they can also be used to augment that assembly, whether it be a press fit, slip fit, shrink fit. But these adhesives then completely seal that, just like in the threaded fasteners. It completely fills those voids, and it seals out any corrosion, any moisture that can get in there. It distributes the stress more evenly, and again, just makes your assembly more reliable. So one of the other things too, and I mentioned earlier with the keyway and the spline shafts, how expensive they are to machine. Well, even machining press fits, although not as expensive, there's a tolerance there that you have to take into consideration. So by using a machinery adhesive or one of our retaining compounds, it allows the engineer or the machinist, whoever it might be, to reduce that bulkiness of the part, or loosen the tolerance. They don't have to be as exact with that, so it doesn't take as much time and cost as much money. And generally speaking, the tighter that tolerance, the higher the cost is going to be when you talk about machining, the machining aspect of it. So, Ryan, I don't know, do you still want to show that, or?
Yeah, I think I'm back.
Okay. Yeah, you're back. I see you, but.
Yeah. Do you see the PowerPoint?
Yes.
Okay. If I drop out, just move on. I'll come back in.
Okay.
Can you see that okay?
Yes.
Okay. So just to give you a quick idea of what Keith is talking about, this is essentially a slip fit, right? You can see the collars moving up and down the shaft with no set screw, nothing holding it in place, okay? So what our retaining compounds are capable of is creating the strength of an interference fit or a press fit without actually using any mechanical machining method or anything like that, just our bare hands. So what I've done is I've taken our 680 retaining compound and essentially adhered this collar to the shaft, and I have a hydraulic press I'm going to use to see how many pounds per square inch it's going to take for me to push this through. And I'll try to set this in a way that you guys can see it. So you see the gauge okay. As I go, you'll start to see the needle move forward. So right there, we probably have about 2,000 PSI, okay, being pressed against the pin, pushing it through the collar. Again, this is nothing but anaerobic adhesive holding it in place. So now I've gotten to about 3,000. Sorry, the light's reflecting off that, but you can see between 2 and 4. Okay, you heard it snap there. I got to about 4,000 PSI before it snapped. And even so, as far as a prevailing strength, this is holding at 2,000. So it's not like the pin's going to shoot out. You still have some added reliability. The anaerobic's still holding on to the shaft as much as it can as I'm pushing more pounds per square inch through it. But just to give you an idea, you got about 4,000 pounds per square inch before that thing slides. And that's using no mechanical locking method whatsoever. That's just adhesive. So just a quick point there to help drive that home.